Hey, this is Bill. I'm checking in with Paul McWhorter's Pico W class, homework 56, where we're dealing with the joystick. We just got off of doing uh, low pass filters and complementary filters, and Paul spent a bazooka of time on that, and I don't know as it's getting pounded through my head the way it should be, and I'm probably showing my ignorance, but this is how I went ahead and was trying to do this. The homework assignment was to try and get the, oh, yeah, you guys can see all the code here. So what we're doing is we're essentially reading X and Y values straight off the Pico from the joystick. Paul added this 65535, which is the max value. He did it on the X because of the readings were goofy and not so intuitive. So this made the world a little more intuitive or expected, and the world is more unexpected than I ever would have believed at this point in time. But anyways, so this is what it is. So what I did was, this is the read thing. And what I did was I took these read values, and we might as well run that, and I'll kind of show you. And you can see, here where the read values are, and the X and Y bounce around quite a lot. And anyhow, since we just got off of all the filter stuff, I was trying to get rid of some of the noise, so I felt, well, and looking at the title of the next class, I kind of thought this was the direction that Paul might be hinting at. So anyways, let me stop that, and we'll go down to the next one. So I added a low pass filter to that with a confidence of 0.005, high confidence, and here you have the 1 minus confidence val times X val. So this is with the low pass filter in there, and let me hit go. And you can still see that it's bouncing around like a banshee, and figure, holy mackerel. That low pass filter doesn't seem to be doing anything really, and I'm probably showing my ignorance and understanding of low pass filters, but that's what I got. Okay, getting on more to what the homework assigned. Let me comment that out. We'll go to the next one. So I did normalize values, and this was the equation I had to normalize the value. And you can see, you can see it over on this side. And I just said I just watched the value of the joystick, and I did the high position for both the X and Y, which turns to be for the Y it was like north, and for the X value it was like east. And these were the most common values that I was getting, and I kind of calculated, I just looked at them, did an average, and strangely enough, the average for the X and Y on the low side of things came out to be the same number. So I figured, the world was smiling at me, but it was 32,472 for both of these. And then when I went to the high values that I said, the north and east, excuse me, a little jet fuel there. The Y came out with this happy number that is the max value, the 2 to the 16th or whatever it is. 65,535, and the X came out to 65,215. So here's the math that I did. You know, slope or M, rise over run. Rise over run is the way it was taught to me back in, you know, when they were trying to figure out Stonehenge and stuff. Anyways, I got that as a slope, 0.003. This one came out to be essentially the same, 0.003. It didn't change to like the 5th decimal point, so I just figured we're close enough. And these are the, you know, take a look at it, y minus y1. This is the math I got, and this is essentially the same, so it came out to be the same value. Hopefully this, my mouse is showing up here, but I'm pointing at the X val, and that's on the first equation, and that's where the value that the pico reads, and the X norm is what it returns and is going to plot. Same deal. Y value is what the pico is going to read, and it's going to plot it with the Y norm on here. So going back to the code, let's run that guy and see where we're at. Well, cool. I can see at least the scale has changed, but we're still getting a hell of a lot of bounce on that. And just to show that this is what the homework asks, okay, I'm going to go max X, and you can see it's not quite at 100, but it's we're in the ballpark. And then you go the minimum or minus 100, and you can see we're not quite there, but we're close, you know, about 0.5% off. We'll look at the y-axis or the orange scale. You know, that looks pretty darn good, actually. We're 99 something or other, so we're less than 1% off. And then we'll go down further, and we're 96.4. That's going pretty fast. So, but anyways, you can see the goal for this assignment was to get it to go from 100 to a negative 100, and we're close. You know, on the Y, I'm off by less than 1%. On the X, it's a little bit more. But you know, still, I've got this low pass filter in my transom here, so let's turn that off, and you can see this is where I did the confidence val, still a 0.005, and I've changed this enough that whatever, you don't need to see that. It's, you know, I'm just not getting it to get the results that I would have expected. And then you subtract it, you multiply by X norm and Y norm here. But let me turn this plot on with the filter and see where it goes. And holy mackerel, it's still bouncing all over like a jumping bean there. I can do X and Y, and you can see, you know, everything's working relatively well. We've still got a little bit of error, but anyway, that's my homework. We'll see you guys on Tuesday, and hope everything's going well. Talk to you later. Bye.